In this video, I want to talk you through how you can use a browser to control the M5 stack dial. This is our Flowcode program, and you can see we've got the usual components here, but we've also now got a communications layer, which consists of three components: a web server, a network comms layer, and a wireless LAN component. And they're all associated with each other, as you can see by the arrows there. The web server will be built into the M5 stack dial along with the Wi-Fi component, and the network comms layer connects the two together. The strategy here is slightly strange. It's not possible to send straightforward messages across the internet for firewall and safety reasons, so we have to be slightly clever about how we send data to and from the web server. Now the strategy is, first of all, we connect to the Wi-Fi. The router will then assign an IP address, in this case 192.168.1.141, and then we create a socket that allows communications to take place between the M5 stack dial and the router. What we can do is we can send messages to the embedded system by requesting different pages. So in this case, if we want to send an enter command, we request the enter.html page. The embedded system detects that that page has been accessed, and then it can open the door. It also, when we send these simple HTML commands, there is a facility for returning text, and so we can return the text door opened. To get information from the embedded system, what we can do is request the page getTemp. Then the embedded system measures the temperature and it returns the relevant data. So this shows you how you can send messages to the embedded system and get information from it with a simple HTML command. Let's see how that looks in the Flowcode program. Let's just move that to one side for the moment. So this is our program. You've seen how we do some of this before. We initialize the temperature sensor, the display, set the backlight, and then we initialize the Wi-Fi component. And that connects to the router. And if the connection is successful, we then navigate down this branch. If it's not successful, we print error and the program goes down that branch. If we're successful, we get the IP string. We then set the color to be white and we print the IP string on the M5 stack dial display. We then initialize the web server and we create a socket. Now the rest of this program here is as you've seen, which is the menu control system. So let's just look at the home screen. The home screen is as it was before, except now there is a command which checks the socket activity on the web server. If there is activity, then automatically this macro HTML callback is called. So what this macro does is it says if enter.htm has been accessed, then go down this branch, and we set the new screen to be the enter screen, and we return the message unlocked. If getTemp has been requested, we measure the temperature and then we return the temperature as a string. We can't return numbers. If neither of those pages has been requested, then we just return the HTML as unknown page. So whenever there is some socket activity, this is the routine that is accessed. The other screens are as normal, with the exception that the enter screen is now turning the outputs on, waiting for 4 seconds, and then setting new screen to be home screen so it navigates back to the home screen. So this shows you how you can send and receive information to and from the embedded system. And let's now see how that works in practice. let's just zoom in to the system. Let's power it up. And now let's have a browser. So here's Chrome. You can see that the hardware is in the home screen, and if I enter http 192.168.141 / enter, then you can see that the system navigates to the enter screen, the relays are activated, and the solenoid is switched on. After a few seconds, it returns to the home screen. So let's do that again. Goes to the enter screen, the relays go on. Now let's also try the get temp. If we navigate to the get temp screen, we can see that it returns a value of 23. So it's measured the temperature using the I2C SHT21 sensor, and it's measured the temperature. And if I put my finger on the temperature sensor and do it again, you'll find it's gone up slightly. So that shows you how you can get information from the M5 stack dial and how you can send information or commands to the M5 stack dial.